Hello, welcome again. We are solving GATE 2021 Aerospace Engineering paper. Question number 48 is the air flow rate through the gas generator of a turboprop engine is 100 kilogram per second. The stagnation temperature at inlet and exit of combustor are 600 Kelvin and 1200 Kelvin respectively. The burner efficiency is 90% and the heating value of fuel is 40 megajoule per kilogram. The specific heat at constant pressure Cp of air and burned gases are 1000 joule per kilogram per degree Kelvin and 1200 joule per kilogram per degree Kelvin respectively. The flow rate of the fuel being used is dash kilogram per second. Round up to decimal places. Note: do not neglect the fuel flow rate with respect to air flow rate. Okay. So let F be the fuel air ratio. So by heat balance, this is the heat carried by exhaust gases 1 plus F goes for 1 kg of air. The total exhaust gases is 1 plus F. Okay, that is the total mass of exhaust gases and CPG into TG. So that is the heat carried by exhaust gases and heat carried by inlet, because at inlet there is only air. Okay, and this heat is supplied by fuel, and fuel for 1 kg of air is F. So F into Cv into burner efficiency. So we have all the values. CPG is your 1200, TG is your 1200, CPA is your 600, TA is your 1000, and calorific value is 40 megajoule. So this is in megajoule. So 40,000, 14,000, 1000, and burner efficiency is 0.9. So F comes out as 0.0243. So this is your fuel air ratio. For MA is equal to 100 kg per second. The mass of fuel is your 2.43 kilogram per second. Okay. So answer is 2.43, because mass of air is 100 kg. So mass of fuel will be 2.43 kg per second. Okay. Next, a rigid bar ABC with roller support at A is pinned to column BD and C at point B and C respectively, as shown in the figure. The other end of the column BD is fixed at D, whereas the column C is pinned at E. A vertical load P is applied on the bar at a distance A from point B. The two columns are made of steel with elastic modulus 200 GPa and have a cross section of 1.5 centimeter into 1.5 centimeter. The value of A, for which both columns buckle simultaneously, is dash centimeter, round up to 1 decimal place. So this is A, and this is your 100 centimeter, this is 75 centimeter, this is 125 centimeter. Okay. So as BD is fixed, as BD is a column and it is fixed at one end and it is pin joined at the other end. And similarly, this is EC is a column which is pin jointed at both ends. So for this column BD, the buckling load is pi square EI by L1 square, because into 2. So that is the fixed end and your pin jointed end. Okay. So it will be pi square EI divided by L1 is your 75 centimeter. So 75 square into 2. Okay. So in case of this column, the C is a pin joint at both ends. So for pin joint, the formula is pi square EI by L2 square. So this will be pi square EI by 125 square. So ratio of these two loads that is carried by fixed and pinned end and at both end pins, P1 by P2 is 2 into 125 square divided by 75 square, that is 5.556. Okay. So the ratio of two loads is 5.56. Okay. And we know that P1 plus P2 is your total P, because P1 is causing buckling in BD and P2 is causing buckling in the second column. Okay, in second column, that is C. Okay, so that P1 and P2 should be equal to P, and P1 and P2 should be equal to P, and the ratio we have found out, that is 5.556. Okay, so putting the value of P1 in terms of P2, that is 6.556, P2 is equal to P, and taking moment about B, uh, taking moment about P into A is equal to P2 into 100. Okay, so P is your 6.556 P2. Okay, so A into 6.556 P2, P2 and 100, so A comes out as 15.25 centimeter. Okay, so answer is 15.25 centimeter.